Our moon, as small as it was compared to Earth, has 5 times the mass of Pluto.
People's imaginations were abruptly caught by the James Webb Space Telescope. We are aware that we could need to alter the entire universe's past. The furthest object in the solar system is the dwarf planet Pluto. Hundreds of thousands of small planets and asteroids call this area of the Kuiper Belt home. Pluto was named after the Roman deity of the Earth, Pluto, and was originally regarded as the 9th planet in the solar system. But in 2006, Pluto lost its standing. Over the past several decades, there has been a significant expansion in our understanding of the cosmos, and we now have a solid understanding of how the world functions, what it is comprised of, and if it is feasible, inherit humanity's future. However, there could still be more to learn about our galaxy's stars. Which enigma surrounding Pluto was ultimately resolved by the James Webb Space Telescope? Is he ignorant of life? Does it include an ocean? Come along as we examine the astounding and enigmatic findings revealed by the James Webb Space Telescope on Pluto. Its moon was the tiniest in the solar system, yet no one noticed. Nobody finds it bothersome that its orbit is elliptical and tilted. Weird as Pluto may be, it's our craziness. It's little enough for kids to understand. Her circumstances could be considered difficult by many grown-ups. Not surprisingly, when Pluto was designated as a star 15 years ago, the people was incensed. Pluto was taken from the list after the International Astronomical Union updated its definition of a planet. The modification procedure stipulates that the Earth has to possess 3 qualities. It needs to spin around the Sun. Pluto is a dwarf planet since it failed the 3rd and last test. When Galileo first saw Jupiter via a telescope in the 1600s, everyone believed that any enormous object orbiting the sky was either the Earth or the Moon. In the 1800s, when astronomers first found the rocks that we now refer to as asteroids, they also named them planets. Pluto was first regarded as a planet. He is presently employed by Flagstaff, Arizona's Lowell Observatory. Tombaugh informed the inspector of his observations right away. "I've located you, Planet X," he said. Beyond Neptune, Tombaugh mentioned a 9th planet that is believed to circle the Sun. An object only 1/10 the breadth of Pluto's orbit was seen in 1992 outside Pluto's orbit. Since then, the coldest area outside of the solar system, the Kuiper Belt, has yielded approximately 2,000 solid objects. There could be more. What connection does Earth have with these odd planets? What caused them to awaken? Astronomers were suddenly perplexed as to how the planet came to be. He found the first object in the Kuiper Belt that seems bigger than Pluto in 2005. These ices originated in the early days of the Sun and planets. According to Brown, Senna ought to be the 10th planet if Pluto is the 9th. However, Pluto also doesn't deserve to be Earth's satellite if Senna doesn't. The investigation was carried out during the Prague conference of the International Astronomical Union. On the final day of the August conference, a vote was held on the updated global definition following lengthy deliberations. Pluto and Senna were designated as minor planets. The Greek goddess of strife, Eris, is now called Senna. This moniker makes sense considering how significant it has been in altering our perception of the Sun. Articles are immediately updated and published. However, a lot of geoscientists haven't altered their strategy, particularly those who are studying Pluto. The International Astronomical Union's definition of a planet is still debatable for valid reasons. To get this knowledge, researchers study a lot of books and papers. There are newspapers dating back hundreds of years. They explain the many meanings of world that the public and scientists use for a variety of unclear reasons. This may be observed in the asteroid belt that lies between Jupiter and Mars. After its discovery in 1801, Ceres and Pluto were classified as planets. As new objects are discovered in the asteroid belt, Ceres is reportedly losing its classification as a planet. Astronomers discovered that Ceres had hundreds of neighbors by the late 1800s. The tradition goes that when Ceres disappeared from view, she lost her worldly rank. Pluto and Ceres have the same destiny. Meyer's group now acknowledges that this is untrue. Ceres and other asteroids were still regarded as planets, or even asteroids up to the 20th century. Thousands of planets are known to circle the Sun, according to a 1951 scientific journal article. However, it's crucial to keep in mind that the bulk of these planets are asteroids, which may range in size from the size of a city block to that of Pennsylvania. For the first time, they were visible from the plane. The planet still seemed like one of the biggest asteroids at that time. Many of the smaller ones, however, are unique. They are not smaller than the bigger planets, as demonstrated by this. You may wonder, what about the Moon? Scientists referred to it as a planet or subplanet until the 1920s. Remarkably, the Moon is still regarded to be a planet despite scientific proof to the contrary. This change in opinion is attributed to non-science media like astrological almanacs. These books' indications are based on planetary alignments. Astrologers claim that it is simple to comprehend why there are so few planets in the sky. In education, the term lost has resurfaced since 1960 in a broad context that encompasses the Moon. To put it briefly, the IAU did not create the definition of Earth. The word's meaning has changed significantly throughout time. It will thus alter once more if required. If the cosmos had hundreds or thousands of planets, how would your life be different? Who are these folks that can recall all of this? What ought to be included in our lunchbox? However, Mill was worried that narrowing the attention to only the 8 planets would keep people from discovering more about the globe. After all, the meaning of the world can just be subjective. There are methane ice flakes as tall as houses on the dwarf planet, and there are nitrogen cliffs that resemble the untamed coast of Norway. More cracks than the Grand Canyon and frozen volcanoes taller than the Himalayas abound on Earth. Millions of fans worldwide were astounded by the footage taken by the plane's camera, which showed what looked to be a massive heart orbiting the Earth. It had been 8 years since the tragedy. Still, they have a fresh perspective on the world. At its closest to the dwarf planet, New Horizons was only able to get precise photographs of Pluto's side facing the Sun due to its speed of 32,300 miles per hour. One of them had been out of the shadows for some time. Scientists are now examining photos of the plane's opposite half, or one side, after examining close-ups from the days prior to takeoff. These photos vividly depict the terrain with up to 1 kilometer of detail, despite their poor resolution. Compared to photos captured by the Hubble Space Telescope while in Earth orbit, this is 250 times more. Scientists are learning new things about this dynamic environment by examining hundreds of photos. These discoveries raise issues about things like whether the seas are covered in ice and how substances from the sky freeze to form the Earth's surface. Even the theory that life may exist on a cold Earth is supported by statistics. For instance, ice cubes that resemble skyscrapers were discovered lately on Pluto's far side, but they now seem to encircle the planet. Its beginnings are therefore among the most enigmatic of the minor planets. This gift has no expiration date. Eventually, in 1996, the Hubble Space Telescope helped scientists discover data about space at a resolution of 310 kilometers. Though hazy, the pictures depict a planet-like body with a density greater than that of Earth and other planets in the solar system. Pluto's power was confirmed in July 2015 when New Horizons saw a heart-shaped star north of the equator. Located in Pluto's left ventricle, Sputnik Planitia is a frozen lake surrounded by massive glaciers that is now recognized to have a major effect on Pluto's energy. Pulses of sublimated ice ascend into the sky as the sun warms the plains, only to descend again at night. Pluto may be beaten by the pulse as well. A peculiar observation was made by Francis Nimmo, an Earth scientist from the University of California at Santa Cruz, and his associates regarding Sputnik Planitia. The first picture of Pluto was delivered to Earth shortly after it was taken, and it showed Charon, the planet's biggest moon, nearly exactly above Pluto. Typically, the chance of an accident is 5%. Rather, models indicate that once the basin created, The seabed started to rise on its own. Ice craters form when nitrogen in Pluto's atmosphere condenses and freezes. The existing relationship between Pluto and extra water and ice is the product of heavy lifting. The disorganized, jumbled hills, fractures, and plain to cross from Pluto's Sputnik plains provide some of the finest evidence. Scientists think that a comet or asteroid collision across Mars, Mercury, and Europa, one of Jupiter's moons, caused a seismic sweep. Similar to Pluto's ice moon Charon, these earthquakes shatter surfaces until they ultimately clash near the horizon. The characteristics were comparable to ones observed elsewhere in sunlight, according to Oliver White, a geologist who analyzed the geology of the isolated location, but was not involved in the study. However, White noted that the image was smaller. The majority of other scientists concur. For a very long time, scientists have hypothesized that after Pluto formed, its water started to cool and eventually froze. Its rocky core eventually releases enough heat from radioactive decay to dissolve it. Ice shrinks and causes surface ripples when it melts. If this is the case, Pluto's face with skin and stretch marks will be seen in the finished pictures. But all that was photographed by New Horizons were the fissures. This implies that the oceans of the dwarf world were formerly liquid, but are currently partly frozen. Images of Pluto's far side, for instance, reveal a massive crater that is the same height as the adjacent Earth. It has spread to the point where it now encircles the whole dwarf planet, from north to south. This rift system splits continents in half, much as the East African rift system splits nations in half. Rifts on Pluto resemble scars from frozen, growing oceans rather than being signs of continental migration, in contrast to rifts on Earth. It seems from the age of the fissures that the waters cooled quickly after being exposed to the atmosphere. If so, the marine ecosystem will flourish there. The complex organic substance, which has a reddish-brown color, is produced in a laboratory by subjecting it to radiation from sources like cosmic rays and solar wind. Thus, this may occur on a planet such as Pluto. Ammonia may also combine to create molecules that are necessary for life, such the bases in DNA and RNA. Pluto's proximity to red ammonia ice is a significant clue that the dwarf planet may be a rich source of chemical molecules. Though most Earth scientists do not believe that life originated on Pluto, this theory suggests that Earth might survive if life were introduced to it. Look for life. They also resulted in a lot of disputes. The discovery of skyscraper-sized ice blocks in the far east of the near-side startled scientists. The ridges, which may occasionally exceed a mile high, or roughly 3 times the height of the State Department in New York City, are perfectly balanced and raised into the sky like a blade in the original photos returned by the James Webb Space Telescope. They have a maximum range of 19 miles. It would be a nightmare to try to navigate around this region. Although the current map is not very detailed, it is evident that the blade-like soil is present across the area and resurfaces close to the western border. The fact that they travel through 3 times, from Pluto's far side to its near side, makes them one of the planet's biggest mysteries. Transport, however, nobody is certain of how they got started. Methane in the atmosphere is thought to solidify and fall to the Earth, much like frost does. These are probably pieces of degraded methane ice from direct sunshine. The second theory was suggested by several specialists because of the strong ridges, which mirrored smaller-scale Andean patterns. Penitent rock grows in the highlands of South America and reaches just a few meters in height. Since the good-hearted person faces the sun and grows up near to the equator, where solar radiation is highest, it is believed that light plays a part in the creation of bravery. Sunlight is thought to be the driving force behind sublimation, the process of cutting teeth-like grooves into ridges. Climate and topography of dwarf planets. Pluto's past illustrates the strength of human knowledge and our never-ending search for knowledge. In parallel, scientists will update current safety requirements to more accurately represent real-world circumstances. Their goal is to simulate as closely as possible the atmosphere and seas of Pluto in a lab setting. The star will be the direct target of the James Webb Space Telescope. Although Webb is unable to capture high-resolution photographs of Pluto, it is still feasible to observe unexpected objects by using longer wavelengths. Pluto, we now believe, will provide an answer to our age-old query: are we alone?
Pluto initially appeared to be a far-off remnant at the frontier of our solar system, simply another frozen, forgotten rock. However, the reality is considerably more remarkable than anyone could have ever guessed. What if I told you that something is concealed beneath Pluto's ice-barren surface? A mystery so vast that it has the power to alter our understanding of the universe? Imagine how shocked scientists would be to learn that Pluto isn't actually dead. It contains subterranean volcanic activity and even the elements that make up life, which have long been concealed from us. How might this affect efforts to find extraterrestrial life? Could the secret to comprehending life in the most unlikely settings lie in the frigid, far-off planet of Pluto? Prepare yourself, because you will be astounded by what has been concealed on Pluto for so long. For many years, Pluto was thought to be a barren, frozen world on the edge of our solar system. It appeared to be a region too far away and too frigid to have any noteworthy characteristics, much less something as surprising as life. However, the James Webb Space Telescope's groundbreaking discoveries are rapidly altering that perception. The apple cart is being disturbed by the James Webb Space Telescope. We suddenly came to the conclusion that we might need to revise every textbook on the universe's origins. Scientists were initially perplexed by some odd data, a signal that suggested something far more than a frozen shell. An subterranean ocean was revealed by the telescope as it swiveled its infrared lenses toward Pluto. For a planet that is so far from the sun and has surface temperatures that can drop as low as -375 degrees, this is revolutionary. How is water able to remain liquid? Unexpectedly, Pluto's relationship with its moon Charon holds the key to the solution. The gravitational attraction between Pluto and Charon creates enough internal heat through a mechanism called tidal heating to prevent Pluto's subsurface water from freezing solid. We never thought that a planet that far away would have a hidden liquid ocean beneath its icy surface. There's more, though. There was more to the James Webb Telescope. Scientists were astounded to discover organic molecules, the foundation of life, in Pluto's atmosphere. Not all organic molecules are indicators of chemical reactions. They are the very components that have the power to create life. Consider this. Once thought to be a dead ice ball, Pluto may really be concealing some of the most basic components required for life. These organic molecules raise the possibility that Pluto's atmosphere is going through intricate chemical processes similar to those on Earth, which might lead to the unthinkable: life on Pluto, or at least the possibility of it. And this begs the question, could life exist far below Pluto's surface if it can hold organic molecules and liquid water? Scientists are excited about this potential, which is forcing us to reconsider what constitutes a habitable planet. Pluto isn't the icy tundra we originally believed, as we discover more. Beneath its cold exterior, this dynamic world harbors secrets that have the potential to fundamentally alter our perception of extraterrestrial life. Not only are these Pluto-related discoveries fascinating, but they are revolutionary. For many years, we thought that life must be dependent on the sun's warmth. After all, everything on Earth is powered by the sun. Because of it, life exists, animals flourish, and plants bloom. But what if sunshine wasn't necessary for life to exist? What if it could flourish at locations so cold and far away that the sun is only a little speck in the sky? This concept isn't as crazy as it seems. There are entire ecosystems on Earth that exist in total darkness in the deepest oceanic regions. Without any sunlight, organisms such as fish, bacteria, and gigantic tube worms are able to survive by using the heat and chemicals emitted by hydrothermal vents located deep within the ocean floor. Despite being far from the sun, life not only endures but thrives in these conditions. And beneath its frozen surface, Pluto might provide just such a habitat. We now know that Pluto is not the icy, dead world we once believed it to be. It has a secret underwater ocean that is kept liquid by a phenomenon known as tidal heating. Pluto obtains its energy via gravitational interaction with Charon, its moon. Pluto and Charon strain and stretch as they move around one another, causing friction that heats Pluto. Even if the surface is a chilling -375 degrees Fahrenheit, this heat is sufficient to prevent its subterranean ocean from freezing solid. It's an intriguing illustration of how life could persist in the absence of starlight. There's more, though. Additionally, organic molecules were found in Pluto's atmosphere by the James Webb Space Telescope. These are the same compounds that are present in Earth's life-rich surroundings and are the building blocks of life. These chemicals' discovery on Pluto begs the crucial question: is there life, albeit microscopic, thriving in that secret ocean? Although we don't yet have conclusive evidence, it is conceivable. It has all the elements required for life: heat, water, and organic chemistry. The answer to the question of whether Pluto contains oxygen is, of course, no. Unlike us on Earth, it lacks oxygen. With trace amounts of carbon monoxide and methane, nitrogen makes up the majority of its atmosphere. However, in environments devoid of oxygen, life on Earth has developed under some of the harshest circumstances. Oxygen is not necessary for the survival of creatures found in the deep oceans, volcanic vents, and other hostile settings. The same may apply to any possible life on Pluto. How strong is Pluto then? Pluto is a very powerful planet in its own right, even though it isn't as big or heavy as Earth. It's more than just a piece of ice near the solar system's border. Beneath its surface, Pluto is a living, breathing entity. There is evidence of complicated geological activity, such as cryovolcanism, as well as an ocean and a dynamic atmosphere. This indicates that Pluto is not as dead as previously believed. Geological processes there have the power to alter the surface and preserve a secret world underneath. Our understanding of the habitability of far-off worlds is being challenged by these discoveries. It begs the question, what else might be out there in the far reaches of space, waiting to surprise us? If Pluto, which was once believed to be a barren ice ball, can support the circumstances necessary for life, finding useful data from such a far and remote environment was the primary obstacle to Pluto exploration. Pluto was too far away from Earth, nearly 4.7 billion miles, for conventional space exploration techniques to reach. Our knowledge of Pluto is limited to surface-level observations due to its extreme cold and lack of sunlight, which prevented it from being investigated with traditional telescopes. This was a crucial problem, since any theory on what might be beneath its cold exterior would remain just that, a theory in the absence of conclusive evidence. The stakes were really high. Being a tiny planet on the edge of the solar system, Pluto served as a metaphor for our lack of knowledge about far-off worlds. As we discovered more about Pluto, we came to understand that it might provide important insights into how planets change over time, how life might exist in unexpected places, and how to reconsider what is required for a planet to host life. It became evident that if Pluto's mysteries were solved, the boundaries of what we consider habitable, not just in our solar system, but across the universe, could be redefined. In order to address these issues, researchers looked to the James Webb Space Telescope for an answer. We were able to see beneath Pluto's thick atmosphere thanks to Webb's amazing infrared capabilities, which gave us hitherto unattainable information on the planet's surface and atmosphere. Webb offered deeper, more accurate data than flybys or surface photos alone, exposing previously unknown elements in Pluto's atmosphere, like as organic compounds. This was a significant discovery since it demonstrated that, despite its frigid and remote surroundings, Pluto possesses the elements necessary for life. Furthermore, it was discovered that the energy source maintaining Pluto's underground ocean liquid was tidal heating, which is the heat produced by the gravitational attraction between Pluto and its moon, Charon. This was the pivotal moment. The ocean is maintained by the heat from tidal forces rather than the sun, which may also offer a favorable habitat for microbiological life. The existence of organic compounds raises the possibility that Pluto may support life, at least in microbial form, which was not a possibility when the planet was originally identified. What are the implications of this for the future? More expeditions, more data, and further exploration of the limits of what we deem habitable are the obvious next stages. The exact mechanisms that sustain life on Earth, organic molecules, water, and energy sources, are present in areas we never would have imagined, despite Pluto's distance from the Sun. The findings here may force us to reconsider the possible locations of life in the universe and have far-reaching effects not only on Pluto, but also on other frozen moons and far-off exoplanets. The answers we've discovered through cutting-edge technology like Webb and the ongoing investigation of our solar system are ultimately increasing the possibilities for what we know about life and our role in the cosmos, despite the enormous hurdles of investigating such a distant environment. It's difficult not to feel both small and important as we gaze out over the enormous, seemingly limitless expanse of space. Pluto, a little dot at the border of our solar system, is far more than scientists previously thought. Hidden for millennia under its frozen surface is an ocean that is warm enough to support life and is formed by the same forces that sustain our own planet. It serves as a reminder that there are many mysteries in the universe just waiting to be unearthed, and that even the most remote, forgotten locations may provide the answers to issues we have only just started to consider. Not only is what we've discovered on Pluto a significant scientific advance, but it also serves as a poignant reminder of the wonder and beauty that exist all around us. In an attempt to comprehend the nature of life, the cosmos, and our position within it, we have always turned to the stars for guidance. We now know that life can persist even under the most trying circumstances. Finding life elsewhere becomes far more feasible if there is life on Pluto, or even if there is the possibility of life there. This Pluton finding raises the question, what else is out there? What other frozen moons, far-off planets, or distant galaxies have mysteries that are just waiting to be discovered? We have only just begun to explore the universe, and Pluto has taught us that the possibilities are much more expansive than we could have ever dreamed. Let us be reminded of one basic fact as we continue to explore beyond the stars. The cosmos is huge, enigmatic, and full of possibilities. The road ahead will unveil even more astounding realities, and the wonders we have already found are just the beginning. Every new finding and inquiry brings us one step closer to realizing the universe's immense beauty and potential, as well as the prospect that we might not be alone in the coldest, most remote reaches of space. We are therefore reminded that the universe is not only outside of us, but also within of us as we gaze at the stars and the numerous uncharted worlds. Let this finding encourage us to continue looking, to continue to wonder, and to continue to have faith that the answers we are looking for are out there, just waiting to be discovered.
Astronomy has made amazing strides thanks to the James Webb Space Telescope, which provides a previously unattainable view into the deepest and most remote regions of the cosmos. Scientists and the general public have long been captivated by Pluto, a minor planet, which is the subject of one of the most important and unexpected recent discoveries. What was formerly believed to be a frigid, desolate world at the fringe of our solar system has proven to be considerably more fascinating than initially believed. The James Webb Telescope has uncovered previously undiscovered, startling new information about Pluto that are fundamentally altering our understanding of this far-off planet. Please remember to like and subscribe to our channel before we begin for additional updates. Before being downgraded to a dwarf planet in 2006, Pluto was ranked as the 9th planet in our solar system. Since then, spacecraft like NASA's New Horizons, which made a flyby in 2015, and now the James Webb, which has given us even more knowledge, have contributed significantly to our understanding of Pluto. Prior to the James Webb Telescope's launch, Earth-based telescopes were used for the majority of Pluto studies, although they were limited in their ability to record detail. NASA had long assumed that Pluto was hiding more secrets than it was willing to admit, but what James Webb found dramatically supported those theories. Scientists have been anxious to investigate Pluto's surface, atmosphere, and the hidden intricacies of its moons ever since the James Webb Space Telescope trained its powerful lenses on the planet. By using infrared equipment, the James Webb spacecraft can see characteristics that were previously hidden behind Pluto's clouds and frozen atmosphere. Beyond Pluto's icy, far-off surface, they discovered a much more active and sophisticated structure than they had ever expected. The finding that Pluto appears to have an underground ocean under its ice surface was among the most astounding. It was previously believed that Pluto was a frozen world that was too frigid to support liquid water. Nonetheless, the information gathered by James Webb implies that Pluto's core generates heat that keeps a subterranean ocean liquid. This finding may significantly alter our perception of potential life locations in the cosmos. One of the necessary components of life as we know it is liquid water, and the prospect that Pluto may have subsurface life has rekindled interest in the quest for alien life. The topic of Pluto's subterranean ocean's existence also calls into doubt Pluto's geological processes. Pluto doesn't seem to be a dead planet. Instead, it seems to be experiencing tectonic movements and cryovolcanism, which is volcanic activity that spews ice forms of water, ammonia, or methane instead of molten rock. The discovery by James Webb of what seem to be cryovolcanoes on Pluto's surface raises the possibility that the dwarf planet occasionally sees ice material explode from its innards. Such activity suggests that the globe is far from static, with forces operating under its surface that are always changing its surface. A significant finding from the James Webb observations is the intricate atmosphere around Pluto. Although Pluto's atmosphere was previously identified by the New Horizons mission, significantly more precise details regarding its makeup and characteristics have been revealed by the James Webb Telescope. Despite its thinness, Pluto's atmosphere appears to fluctuate significantly based on where it is in its extended orbit around the Sun. Pluto's atmosphere vaporizes again when it gets closer to the Sun, but it freezes and falls to the surface as it gets further away. Sublimation is a cyclic process that is far more dynamic than previously believed. Furthermore, unexpected gases in Pluto's atmosphere have been discovered by James Webb's infrared capabilities. These gases may include residues of organic molecules that were created by biological or chemical activities in the atmosphere. Pluto's atmosphere contains organic chemicals, which raises more questions about the potential of life on this far-off planet. The basic blocks of life are organic molecules. Although the precise makeup of these substances is still being investigated, their existence begs intriguing questions regarding whether or not rudimentary life forms have ever lived on Pluto. Could life exist in the icy, hostile environment underneath Pluto's surface? Although it is too soon to provide a conclusive response, the finding of organic chemicals raises intriguing possibilities regarding the existence of a subterranean ocean. It has also become clear that Pluto's surface is significantly more diverse than originally thought. High-resolution photos taken by James Webb reveal a very varied terrain. Huge expanses of nitrogen ice blanket Pluto's surface, dotted with water ice mountains and enigmatic red areas that scientists surmise may be tholin deposits, complex organic compounds produced when methane interacts with cosmic rays or ultraviolet light. These tholin deposits may include information on the chemical activities occurring on Pluto, and they may even bear similarities to the primordial chemistry that existed on Earth prior to the emergence of life. Along with these findings, there is now a revived interest in Pluto's moons. It was originally believed that Pluto's biggest moon, Charon, was geologically dormant. James Webb, however, has noticed indications of recent tectonic activity. Large cracks and canyons may be seen on Charon's surface, which suggests that at some point in its past, internal heating may have also occurred there. This begs the issue of whether, like Pluto, Charon may have a subterranean ocean, albeit the evidence is not as strong on this point. However, the prospect that liquid water may be present under the surfaces of both Pluto and its moon has sparked intense astrobiological study in the once peaceful outer regions of the solar system. The orbital dynamics between Pluto's moons and Pluto itself is one of the most mysterious features of Pluto. James Webb's investigations have shed fresh light on the interactions between these moons and Pluto. Some of Pluto's smaller moons, for example, seem to have chaotic orbits, tumbling across space in an unpredictable manner. The intricate gravitational interactions that exist between Pluto and its 5 moons are probably the cause of this. Given that Pluto and its moons are believed to be leftovers of the Kuiper Belt, an area of space populated with frozen bodies left over from the solar system's birth, learning more about the dynamics of these moons might provide important details about the early history of the solar system. What these new findings indicate for the future of space travel is one of the main concerns that emerges from them. Pluto and its moons appear to be much more than just lifeless, frigid remnants of the solar system's ancient past, according to data obtained by the James Webb Telescope. Rather, they are dynamic planets with intricate atmospheres, active geological processes, and perhaps even the conditions required for life. This suggests that comparable surprises may be hiding on other far-off objects in the Kuiper Belt and possibly beyond. Furthermore, the location of potential search sites for extrasolar life are affected by the finding of a subterranean ocean on Pluto. The habitable zone, or the area surrounding a star where liquid water may exist on the surface, is where planets and moons have traditionally been the focus of searches for alien life. However, Pluto is well beyond this zone, yet it appears to contain the parameters essential for liquid water to exist under its surface. This implies that liquid water, and perhaps even life, may be present on other frozen worlds, even ones that are distant from their parent stars. Scientists may now be more inclined to investigate other minor planets and moons in the outer solar system, such Europa, Enceladus, and Triton, which are all believed to contain subterranean seas, in light of the circumstances found on Pluto. These findings have consequences that go well beyond our solar system. Similar things may exist in other solar systems if Pluto, a tiny ice world, can have an active geology, a complex atmosphere, and maybe even an ocean. Pluto lives in the Kuiper Belt, which is only one example of an area of space full with tiny, frozen worlds. There are probably Kuiper Belt-like areas in many more solar systems, and the objects therein may be as active and unexpected as Pluto. One day, the James Webb Space Telescope may find habitable planets around far-off stars thanks to its capacity to look into distant star systems, creating new avenues for the hunt for extrasolar life. The significance of continuing to invest in space exploration and technology is further highlighted by the findings made on Pluto. The most potent space observatory ever constructed, the James Webb Telescope, exemplifies the enormous significance of such endeavors with its capacity to unveil the hidden intricacies of far-off worlds like Pluto. We are continuously reminded that the cosmos is full of surprises and that there is still a great deal we do not know about the worlds around us as we push the boundaries of what we can perceive. Pluto, which was formerly thought of as the planet that was forgotten at the frontier of the solar system, is now the focus of scientific study, serving as a reminder that even the farthest objects in space may provide clues to the answers to the bigger riddles of the universe. The discoveries made concerning Pluto by the James Webb Space Telescope, James Webb, are igniting interest in the solar system's outer regions once again. What used to appear to be a cold, barren planet is now understood to be the product of intricate processes, active geology, and perhaps even the birthplace of life's basic elements. The ramifications of these discoveries, when further study is conducted, might go well beyond Pluto itself. They could have an impact on our knowledge of how planetary systems work, the possible evolution of life, and the locations of analogous occurrences elsewhere in the cosmos. The fact that the recent discoveries on Pluto contradict our long-held beliefs about the circumstances necessary for life is one of their most fascinating features. The habitable zone, the area where liquid water may persist on a planet's surface due to temperate temperatures, has been the main focus of the hunt for life for many years. Pluto appeared to be far beyond of any livable zone as it sat at the icy border of the solar system. The criteria for the hunt for life, however, have changed with the finding of a deep ocean, suggesting that liquid water may survive in even more harsh circumstances than previously believed. Though it may sound like science fiction, there is scientific evidence to support the potential of life on Pluto. If there is an ocean below the surface, it may be protected from the extreme weather on the surface by a thick layer of ice, similar to the seas thought to exist on the moons of Jupiter and Saturn, Europa and Enceladus, respectively. Internal heating processes, such as the remaining heat from Pluto's creation or the gravitational interactions between Pluto and its moons, might keep these seas liquid. These kinds of habitats could offer pockets where life could exist, protected from the intense radiation and cold that characterize the dwarf planet's surface. Apart from the prospects for life, Pluto's intricate atmosphere is gaining a lot of attention. The atmosphere is behaving differently than previously thought according to the James Webb Space Telescope's comprehensive infrared studies. Although methane and carbon monoxide are present in minute amounts in Pluto's atmosphere, the James Webb Space Telescope has found evidence of more sophisticated organic compounds. These molecules may be created by photolysis, the process of sunlight interacting with Pluto's surface ices, or by cosmic rays interacting with Pluto's atmosphere. These substances are interesting because they are frequently intermediates in more sophisticated organic chemistry, the type that might potentially result in nucleotides or amino acids, the building blocks of life. Additionally, these findings imply that Pluto's atmosphere is significantly more dynamic than previously believed. Pluto has dramatic seasonal variations while it travels along its 248-year elliptical orbit. Its atmosphere grows when surface ices sublimate into gas at its closest point to the Sun. This atmosphere condenses and freezes back onto the surface as it gets further away from the Sun. The results of James Webb suggest that these procedures may not be as simple as previously thought. Possibly because to Pluto's distinct geology and interior heat, complicated interactions between the surface and atmosphere appear to be occurring as Pluto advances away from the Sun rather than a progressive loss of atmosphere. These discoveries contribute to the increasing understanding that Pluto is a dynamic planet that is always changing, rather than a straightforward, inert entity. Another topic of significant interest is how Pluto's moons, especially Charon, have shaped the ecosystem around the dwarf planet. With a mass around half that of Pluto, Charon has a strong gravitational pull on its parent planet. This interaction influences Pluto's atmosphere's behavior in addition to causing the tidal heating that might maintain Pluto's interior ocean in a liquid condition. Pluto's atmosphere may be distorted by Charon's gravitational force, which might add to the unusual dynamics that James Webb has seen. Furthermore, Charon itself exhibits surface characteristics that point to a past of tectonic movements and potentially cryovolcanism, indicating signals of geological activity. This begs the issue of whether Charon, too, is capable of supporting a subterranean ocean and what that would entail for the possibility of moons in the outer solar system being habitable. New information about the past of Pluto and Charon has also been made possible by James Webb's investigations of these celestial planets. Pluto's surface is cratered, a sign that it has been hit by debris from the Kuiper Belt, an area beyond Neptune that is home to frozen planets and solar system leftovers from the early era. Nonetheless, several areas of Pluto, including the enormous expanses of nitrogen ice called Sputnik planitia, seem to be quite fresh and have few impact craters. This implies that Pluto has recently resurfaced, most likely as a result of tectonic or cryovolcanic events in the Earth's crust. Likewise, the shattered surface of Charon indicates a past of geological activity and interior heating. These findings suggest that Pluto and its moons are living planets that have changed over billions of years, not ancient artifacts stuck in time. Comprehending Pluto's geological and atmospheric mechanisms is essential to assembling the larger picture of the solar system's genesis and development. One of the biggest objects in the Kuiper Belt, which is believed to have some of the solar system's oldest and most primordial material, is Pluto. Scientists can learn more about the early history of the solar system, including how the planets originated and moved to their present locations, by examining Pluto. New insights into the chemical makeup of Pluto's atmosphere and surface are being offered by the James Webb observations, which may aid scientists in comprehending the mechanisms that form not just Pluto but also other Kuiper Belt objects. It also clarifies the more general issue of how planets and their satellites interact, given the intricate relationship between Pluto, its moons, and the surrounding space environment. For example, Pluto and Charon have a unique gravitational connection in the solar system. Because of its size in comparison to Pluto, Charon and Pluto are frequently referred to as a twin dwarf planet system. Because of their tidal locking, which keeps both bodies facing the same way, the geology and atmospheric dynamics of both are impacted. Scientists are learning more about the formation and evolution of these systems thanks to James Webb studies, and this knowledge may have ramifications for our comprehension of exoplanetary systems. The surprising information from Pluto has caused other ice worlds in the outer solar system to be reassessed. If Pluto, a planet long believed to be lifeless and frigid, can display such intricate activity, imagine what may be occurring on other objects in the Kuiper Belt or on the moons of gas giants such as Neptune and Uranus. Scientists are using the telescope to explore other faraway objects, such Triton, the biggest moon of Neptune, which is likewise believed to contain a subterranean ocean and a geologically active surface. This is because James Webb's discovery of Pluto's hidden secrets has inspired scientists to employ the telescope for research. These discoveries have the potential to transform our knowledge of the outer solar system and offer fresh opportunities for the hunt for life. The possibility that the Kuiper Belt and possibly even the Oort cloud beyond it contain more objects like Pluto, dynamic worlds with complex geologies, atmospheres, and possibly even the conditions necessary for life, is one of the most exciting implications of James Webb's discoveries on Pluto. Pluto is only one of the numerous planets that make up the huge and mainly unexplored Kuiper Belt. Scientists are starting to delve deeper than ever into this far-off frontier thanks to the James Webb's powerful equipment. We may uncover many more shocks as we continue to explore the farthest reaches of the solar system. The findings revealed on Pluto are only the tip of the iceberg. The discoveries made by James Webb have consequences that go beyond our solar system. Pluto's dynamic geology, complicated chemistry, and possible liquid water environment raise the possibility that exoplanets and exomoons in other star systems are going through comparable processes. Other tiny, frozen worlds circling far-off stars may have similar characteristics to Pluto's, which have allowed it to maintain its geological activity and potentially even contain liquid water. Scientists are already using the James Webb Space Telescope to explore exoplanets, and the insights Pluto provided may aid in the interpretation of the data these far-off worlds provide. Specifically, the finding of organic chemicals in Pluto's atmosphere may serve as a model for locating analogous substances on exoplanets, which may be a crucial sign of the possibility of life. Traditionally, Earth-like planets in their stars' habitable zones have been the focus of the hunt for extraterrestrial life. But Pluto's findings are changing that emphasis. If a tiny, frigid globe at the fringe of our solar system can support liquid water and complicated chemistry, then other far-off worlds, even ones that are far from the warmth of their parent stars, may be able to support the same circumstances. Using its cutting-edge equipment to explore the atmospheres and surfaces of exoplanets and exomoons in search of water, organic compounds, and other possible indicators of life, the James Webb Space Telescope is positioned to play a significant role in this mission. Furthermore, the discoveries made on Pluto are compelling scientists to reevaluate existing theories on the creation and development of planets. Pluto's dynamic geology and interior ocean indicate that even tiny bodies may hold onto enough heat to sustain major geological processes. This calls into question the conventional wisdom that only massive planets, with their dense atmospheres and powerful gravitational fields, are capable of sustained geological activity. Pluto is a dwarf planet on the outside of our solar system. If it can sustain this kind of activity, imagine what kind of dynamic other tiny worlds there may be in the cosmos. This implies that we might need to reconsider current planetary science models and has significant ramifications for our comprehension of the evolution of planets and moons. In addition to raising questions about the possibility of life on Pluto, the surprising finding of a subterranean ocean provides important new information about planetary geophysics. It defies conventional wisdom to think that a planet this distant from the Sun could have an interior ocean, which would contradict theories about how planets retain heat and continue to be geologically active for billions of years. Internal heat is sustained on Earth via plate tectonics, radioactive decay, and the effect of a relatively nearby sunday. Considering Pluto's tiny size and distance from the Sun, one would assume that it is geologically dead. The results of James Webb, however, point to the opposite. This has prompted research into potential backup systems that would enable heat retention in these kinds of frigid bodies. Tidal heating brought on by Pluto's and its moon Charon's gravitational interactions is one theory. Because these two bodies are in close orbit, their gravitational pull on one another causes their innards to expand and compress, which may produce enough heat to prevent subterranean waters from freezing over. Although moons like Europa and Enceladus have previously shown signs of this kind of tidal heating, Pluto's evidence of such activity was unexpected. Pluto's liquid water presence suggests that the planet may have unusual geological formations powered by cryovolcanism. When volcanic activity results in the eruption of volatile materials such as water, ammonia, or methane rather than molten rock, it is referred to as cryovolcanism. Pluto's surface may occasionally be altered by the periodic releases of water and other materials from the core of these ice volcanoes. Finding such characteristics would be revolutionary, demonstrating that geological activity can occur on tiny, cold worlds near the solar system's periphery in addition to massive core planets. This suggests that other ice dwarf planets and moons dispersed throughout the Kuiper Belt and beyond may share comparable dynamics. Some of the most puzzling surface features of Pluto, including Sputnik Planitia, a large, heart-shaped plain of nitrogen ice, may become clearer with the assistance of these observations. Few impact craters in this region indicate that it is geologically young, indicating that it has just recently resurfaced. The resurfacing of Pluto may be caused by heated material rising to the surface from the subterranean ocean, regenerating the surface in a manner akin to Earth's mantle plumes, according to some scientists. This creates the intriguing potential that we may be seeing continuing geological processes on Pluto that may still be operating today and that have recently changed the planet's surface. Wide-ranging effects on planetary science will result from the confirmation of these geological processes on Pluto, especially with regard to our comprehension of the evolution of tiny, ice planets. The suggestion is that Pluto is a dynamic entity with continuous geologic and maybe hydrologic activity, rather than a frozen, immobile remnant of the early solar system. These results may indicate that additional objects in the Kuiper Belt, such Haumea, Makemake, and Eris, may also have comparable interior systems, with active geology and subterranean seas concealed behind their frozen exteriors. This theory may ultimately be confirmed or disproved by the James Webb Space Telescope, which has the unmatched capacity to examine these far-off objects. This would result in a significant increase in our understanding of the outer solar system. Not only do these discoveries concerning Pluto have implications for the Kuiper Belt, but they also call into question our understanding of other nearby celestial entities, such as the moons of gas giants. Because of the potential implications for alien life, the discovery of interior seas on moons like Europa, Enceladus, and potentially Ganymede has already created a great deal of interest. Considering that Pluto has been shown to have comparable circumstances, how widespread are these interior oceans across the solar system? Could they be found on additional dwarf planets in the Kuiper Belt or on smaller, less explored moons around Neptune and Uranus? The number of possible habitats for life might be substantially increased by the discovery of internal seas across such a wide range of conditions, suggesting that they may be more common than unusual. The discoveries made by James Webb on Pluto have ramifications not just for planetary geology but also for astrobiology. One of the essential components of life is liquid water, and the hypothesis that Pluto may have a subterranean ocean raises intriguing concerns about whether or not it may be habitable. Pluto's subterranean ocean may have more hospitable circumstances than its surface, which is much too frigid to host life as we know it. Similar to the hydrothermal vents present in Earth's seas, chemical interactions between the water and rocks may provide energy if this ocean is in contact with the planet's rocky core. Even in the absence of sunshine, hydrothermal vents on Earth supply the heat and chemical energy required to sustain complex ecosystems. Numerous species, ranging from bacteria to tube worms, may be found in these habitats and are adapted to survive in harsh conditions. It is possible that microbial life, supported by chemical energy instead of solar radiation, may live in Pluto's subterranean ocean if comparable circumstances are met.
You won't believe what NASA discovered on Pluto, according to Braincox. After NASA's New Horizons mission passed by Pluto, our understanding of the planet was drastically altered. During its brief journey, we discovered something new about the locations in the universe where life can flourish. Many new things were discovered by the New Horizons spacecraft, and we are still learning about them now. Join us as we investigate the waters beneath Pluto to see what is there. We'll witness odd activities, enormous mountains, and freezing landscapes. The water on Pluto might contain life. The possibility that Pluto has an ocean beneath the vast layer of ice covering its surface was one of the most unexpected discoveries. According to some experts, including renowned physicist Brian Cox, there may even be life in this ocean. How could that be? Pluto has the solution in his heart. The planet Pluto is similar to another planet. Pluto, like Jupiter's moon Europa, has an ocean beneath its surface, as evidenced by the fact that it is a frigid wasteland covered in massive water ice mountains and frozen flows. The mission scientists are in awe of what they have witnessed. They didn't anticipate discovering such substantial amounts of fresh ice, despite the extreme cold. The idea that this ice is thick enough to alter the land's shape is absurd. The possibility that Pluto might only have a rocky core surrounded by a frigid shell thrilled the experts. But that's not all. According to team member William McKinnon, this frozen structure increases the likelihood that an ocean lies beneath the ice. They have also discovered water ice on Pluto's highlands for the first time. The head of the New Horizons project, Alan Stern, is certain that there is a lot of undiscovered water in the world. However, there was insufficient evidence, even in 2015, to conclude that Pluto did contain an ocean beneath it. The items discovered were only clues. That was a long time ago, though. Since then, researchers have been putting a lot of effort into figuring out the million-dollar question. Why is Pluto's ocean so important to everyone? The reason for this is that Pluto's ocean portends many things, including the potential for life. How could life, however, survive in such a cold ocean? According to Brian Cox, there is a chance that life could exist on Pluto. According to Brian Cox, this water is sufficiently warm for life to exist. It amazes me to think that there could be organic chemistry and life on this little world. Brian Cox is fairly certain that this concept will succeed. He believes that Pluto most likely has its own inhabitants if our understanding of life on Earth is even remotely incorrect. However, the New Horizons spacecraft may not be able to confirm if there is warm water on Pluto's surface. Finding conclusive evidence on this peculiar ocean is difficult, Cox said. He suggests that we focus on researching the moons of planets that are nearer Earth instead. Titan and Enceladus, two moons of Saturn, and Europa, a moon of Jupiter, are excellent areas to search for evidence of extraterrestrial life. According to Cox, Enceladus even shoots liquid into space, while Titan appears to have an ocean beneath its surface. We may search for organics and swiftly move through that. Despite the intriguing notion of Pluto's hidden ocean, it appears that our best chance of discovering evidence of life is on the moons of other planets. Going from primitive single-celled organisms to sophisticated multicellular beings is like trying to squeeze through a very tight opening, according to Brian Cox. Only a tiny portion of worlds with life will have more than biology because it's so difficult. According to Cox, complex life is most likely uncommon in the world. He does, however, make an intriguing observation regarding what we have discovered thus far. Life exists on Earth as long as there is water. It makes logical to believe that life could exist in the ocean on Pluto, because the materials that make up our solar system are comparable. However, Cox consistently advises people to have less hope. This talk does not contain any large, high-tech creatures. If life exists on Pluto, it's probably incredibly basic and uncomplicated. Complex life is uncommon, but any indication of extraterrestrial life, no matter how basic, would amaze us. Ultimately, because they still don't know much about Pluto, scientists believe there is a good chance it may support life. Jupiter is a heart-shaped planet. Life on Pluto begins and finishes in the center of the planet. A heart that NASA discovered on Pluto is causing the planet to perform a number of things. This heart is a massive nitrogen iceberg that is 1 million square miles in size. In the center, on a location known as Sputnik Planitia, sits the greatest glacier in the solar system. Astronomers first believed that Pluto's distinctive morphology resulted from a violent collision with another large object in the past. However, we are curious about the peculiar location of this pond. It is situated immediately opposite Pluto and opposite Charon, its brightest moon. It might not have been an error because an impact might not have occurred in that precise location across from Charon. Polar wander, which occurs when a planet shifts its spin axis as a result of significant geological processes, is thought to be the source of the alignment between Charon and Sputnik Planitia. Sputnik Planitia is currently located there because it is a suitable location for chilly weather. A massive sheet of ice, at least 2.5 miles thick, has formed due to the accumulation of nitrogen ice. Only if Pluto has an ocean beneath its frozen surface can this event occur. Pluto has shifted its orientation to face its moon Charon as a result of this basin. Interestingly, the basin tilted and aligned more closely with the axis of gravity between Pluto and Charon as a result of the heavy ice and Charon's pull on Pluto. This alteration is probably what caused Pluto's surface to fracture and create those massive faults that run the length of the planet. In the northwest, close to Pluto's north pole, the valley first formed. If more ice continues to accumulate in the basin, Pluto will continue to shift its location. These discoveries shed light on the evolution of even the most enigmatic and distant objects in our solar system. However, there are still many unanswered questions regarding Sputnik Planitia. The mystery of Sputnik Planitia. Brian Cox discussed an intriguing discovery scientists made on a particular region of Pluto in his BBC program, The Planets. There they noticed something really odd. Most people just refer to this region of the sky as Pluto's heart, but Brian Cox termed it Tombaugh Regio. Right on the edge of this region is a range of mountains that rise up to 6 kilometers above the plain below and are composed of frozen water ice. Even weirder is the fact that this location is distinct from the rest of the dwarf planet. Sputnik Planitia is distinct from Pluto, which has a surface covered in craters from strikes that occurred over billions of years, as Dr. Cox stated. There are no visible craters, and it is extremely smooth. It's fascinating that this area of Pluto defies convention and is unique from the rest of the planet. You will never see anything like this anywhere else in our solar system. An intriguing network of polygonal forms is carved into the ice on the surface of Sputnik Planitia as you zoom in. They are all at least 10 kilometers long. Under a microscope, they resemble cells, but they are not. These shapes actually demonstrate how Pluto's heat is frantically attempting to escape from beneath the glacier. As a result, rising and falling nitrogen ice bubbles form, creating a lava lamp-like appearance. Because they differ from anything we have observed in the glaciers of Earth or any other place in the solar system that we have examined, these shapes are highly intriguing. It seems evident from a distance that Pluto has no impacts, but as we approach, the mystery becomes more complex. Detailed images of the frozen nitrogen surface captured by New Horizons reveal a complex pattern of pentagons and hexagons spanning the whole surface. Although there is a suggestion that comparable patterns may exist in other parts of nature, this odd occurrence is still extremely odd. Convection, which warms and pushes objects about, is the reason behind the odd patterns observed on Pluto's surface, according to Dr. Cox. The substance, in this case nitrogen ice, rises, cools, and finally falls as a result of the heat source. Thus, the area is kept fresh by the currents, which is what gives these designs their distinctiveness. It was shocking to learn that a very little world like Pluto is still living. However, where is the source of this heat? Some believe that the presence of radioactive materials in Pluto's core is the reason of this. The nitrogen ice may be melting and rising and falling as a result of these elements' breakdown and heat release. Pluto appears to be far more active than previously believed because of this continuous activity. This discovery is just another indication that Pluto might have an undiscovered ocean of water beneath its surface. But can we be certain that Pluto has an ocean? The information acquired suggests that there might be more to the story than meets the eye. Sputnik Planitia had a greater mass beneath it, according to the data from New Horizons, which probably contributed to its reorientation. This larger bulk may represent an ocean of water, according to scientists. This theory is supported by a number of pieces of data, including the tectonic patterns shown in the images captured by New Horizons. These characteristics imply that Pluto has an ocean beneath its surface. Sputnik Planitia is believed to have formed approximately 4 billion years ago, most likely as a result of a massive impact by a Kuiper Belt object that was 50 to 100 kilometers large. Pluto's icy crust was severely damaged by this collision, leaving only a thin, delicate layer on the base bottom. This hole would then have been filled in by an ocean beneath the top, which would have applied pressure on the crust, strengthening it. Over time, the nitrogen ice layer that is visible on the surface was added. Scientists believe this liquid ocean may have formed extremely fast based on images of the planet. Although they are not proof, these findings strongly suggest that Pluto may have an ocean. Did you know that scientists formerly believed Pluto evolved slowly from cold stuff? That's why Pluto's ocean is what it is. They believe that the dwarf planet gradually accumulated rock and ice as space debris orbited the sun. An ocean would have formed beneath the surface if any of the ice had melted due to the heat inside. Given that radioactive elements may give the ocean the heat it needed to survive, this explanation made reasonable. A study that was published in June 2020 tested this theory. The scientists intended to investigate the possibility that Pluto was once hot and formed by a sequence of large collisions, similar to how Earth originated in its early history. This study's intriguing conclusion is that Pluto's hidden liquid ocean has most likely existed for billions of years. This discovery raises the possibility that our solar system's outer regions include a large number of subterranean oceans. This excites those who are looking for extraterrestrial life. Pluto and its ocean beneath the surface were starting to take shape, but Earth remained a roaring mass of molten rock. Water has been flowing on this distant world ever since, which may make it a suitable habitat for life. The study gained a fresh perspective on Pluto's formation by contrasting computer models with data from the New Horizons mission. Remarkably, it implied that Pluto had an ocean beneath its surface and was quite hot when it originated. This pioneering work challenges earlier scientific theories on Pluto's formation. Additionally, it demonstrates that liquid seas, previously believed to be exclusive to Earth, are present on dwarf planets in the outer regions of our solar system. These findings are critical, according to astronomer Alan Stern, who oversees NASA's New Horizons project. Everything changes if seas are rather abundant rather than extremely rare in the outer solar system. We can learn more about the potential for life on other celestial objects thanks to this new information, which is exciting. According to Stern, it will alter our perspective on the solar system. Scientists were astounded at Pluto's complex and colorful surfaces as the New Horizons mission passed by it in 2015. They started to suspect that beneath the frozen surface might lie an ocean. Over time, these ideas have become more powerful. The majority of planetary scientists today concur that Pluto does have a liquid ocean that encompasses the whole planet. The study's principal author is Carver Barron, a graduate student at the University of California, Santa Cruz. He claims that we have learned a great deal about the inner solar system thanks to asteroids and other information sources. Pluto's location in the inner solar system is well understood, but the outer solar system is less so. The study's objective is to close some of those gaps and improve our understanding of global events. Is it better to start it hot or cold? So, was Pluto hot or chilly at birth? How are we going to solve that? This study provides a solution to that query. It turns out that one clever method to determine whether Pluto originated hot or cool is to look at its surface. It has to deal with the behavior of water during freezing and thawing. According to Stern, this is analogous to placing a glass of water in the freezer. Overnight, the glass will break. The reason for this is that when water freezes, it becomes larger. Pluto experiences the same thing. When water freezes, its molecules slow down and organize into a crystal form. The ice becomes thinner as a result. For this reason, ice cubes rise in your drink and frozen water is larger. Therefore, Pluto's surface should have developed if it was first hot and then gradually cooled, leaving behind geological features created by the growth. However, Pluto's surface would have been crushed across its several paths if it had been frigid in the first place. To determine which scenario best matches the facts, the scientists carefully examined the data from the New Horizons probe. What they discovered astounded them. There were no indications of compression, and they observed portions of Pluto that appeared to be incredibly old, possibly as old as the solar system. This indicates that Pluto got off to a great start, according to Carver Barron, who was also involved in the study. Here's an example to support the claim that Pluto got off to a great start. A common perception of icy planets is that they are tidy circles formed by collisions. However, in the case of Pluto, the holes have widened with time. It's odd that none of them exhibit any indications of compression, even in the oldest sections. There are further bits of evidence as well. Carver Barron created a model of Pluto's early formation using a hot start scenario. If Pluto had formed as a result of successive large impacts, it was discovered that the heat from those explosions would have kept the ocean within the planet liquid. However, Pluto would have needed to form very quickly, less than 30,000 years at most, for this to have occurred. This theory is intriguing because it aligns with emerging theories about the early formation of the Kuiper Belt, which is located beyond Neptune and is home to numerous tiny planets and icy objects. It is believed that small objects in the Kuiper Belt develop quickly, most likely within a few hundred to 1,000 years. The fact that the rocks are guiding us in this direction intrigues Pearson. The same findings are being reached by scientists who investigate the movement of the Kuiper Belt. Additionally, he claims that the notion that Pluto had a heated start is an odd and unusual response. In addition to Pluto, the nearby dwarf planets Eris, Makemake, and Haumea also benefit from the theory that Pluto formed in a catastrophic explosion. Other minor planets, like Pluto, might have formed hot and fast. The long-held belief that Earth is the only ocean world in the solar system is brought into question in light of this new evidence, as well as what is known about the icy moons that orbit gas giants. Our solar system may contain liquid water in its most remote regions. According to Stern, both the inner and outer universes may contain a large number of worlds with seas. This is regarded as one of the most significant discoveries in the history of planetary research. These bizarre worlds might not appear capable of supporting life at first glance. After all, Pluto receives very little light because it is just 4 billion miles from the Sun. As a result, the surface is extremely cold, roughly minus 400 degrees Fahrenheit, 33 Kelvin. But under the warmer water beneath Pluto's ice surface, away from radiation and asteroid impacts, life might be able to endure. Stern discusses the potential benefits of this for life. The fact that submerged oceans are safer for life in many respects is fascinating. The asteroid strike that wiped out the dinosaurs is not likely to happen to you. If there were a supernova or solar flares from the Sun, you wouldn't be in risk. Pluto has had an active ocean for a very long time, as evidenced by this recent discovery. The New Horizons project manager acknowledges that the evidence they have concerning Pluto's ocean is unclear. Rather, he compares it to shaky evidence in court, which may not be sufficient to convict someone. For this reason, he and a team of other scientists are advocating for a spacecraft named Pluto Orbiter that would begin orbiting the small planet in addition to returning to it. Only a small portion of Pluto was visible to the New Horizons spacecraft during its approach, and only 40% of the distant planet was captured in high-quality images. We're shocked at how much we've learned just a quick pass. In addition, 40% of the surface was too dark for New Horizons to see anything. However, radar and laser sensors aboard a Pluto orbiter might be able to read the surface without the need for visible light. According to Stern, an orbiter is required to confirm Pluto's ocean existence. He contrasts this with the discoveries made by Galileo and Cassini, which demonstrated that Europa and Enceladus, respectively, had oceans. Addressing the concerns brought up by the New Horizons project is the goal of the PANI mission. We learned a lot about Pluto and the Kuiper Belt objects from the New Horizons mission, but it also raised more questions than it resolved. These were significant questions, such as the internal structure of Pluto and Charon and the evolution of Pluto and Kuiper Belt objects. But whether Pluto actually has an ocean is the most crucial question. In order to accomplish these puzzles, the Penny expedition will need to carry a lot of items and employ two distinct approaches. In order to conduct a thorough investigation of these celestial entities, the object will circle Pluto and intend to encounter other Kuiper Belt objects, KBOs. However, how much time will it take to reach Pluto? About 27.6 years, even with the assistance of Jupiter's pull. Because it must spend 3 more years orbiting Pluto before moving on to Kuiper Belt objects, the entire mission will take 30.7 years. Pluto is difficult to reach, as the New Horizons mission demonstrated. It took them 9.5 years to sail by Pluto between 2006 and 2015. However, it would take more than 27 years for Pani to reach orbit around Pluto and its moons. This extended period is due to the difficulty of entering orbit. The researcher for the Pani mission concept, Dr. Carly Hout, discusses the difficulty of the task. Because Pluto is so far away, she explains, it is exceedingly difficult to get a travel into and around the Pluto system. The spaceship will have a long cruise period because it must approach the Sun gradually in order to enter orbit. The spacecraft will arrive sooner if it travels faster, but it will require more fuel to slow down and avoid passing Pluto, which will increase the length and expense of the journey. Our current generators won't survive more than 30 years. Thus, we also need a more contemporary power source. Regardless of the length of the mission, 18 or 27 years, the journey to Pluto is a lengthy one, spanning an entire childhood, not including the time required for construction and operation. Even though the task will take a long time, Hout feels it is still necessary. Although the New Horizons mission left us with many unanswered concerns, it also demonstrated the fascination and diversity of the objects in the Kuiper Belt. Since it takes decades to reach these far worlds, we must make a decision fast. Over the next 50 years, we must find answers to these concerns and gain greater knowledge about the region. Pani's goal could be the solution we require. Let's now discuss expenses. For Pani, we would need to spend above $3 billion. Given the substantial financial outlay, it is crucial to ensure that the objective is truly worthwhile. Although the New Horizons mission gave us the closest up look at Pluto ever, it was only a single point in time, so the data it collected isn't ideal, particularly when it comes to describing how Pluto's surface evolves, how its atmosphere functions, and its volatile past. However, Pani offers us a unique opportunity to observe the Pluto system's time fluctuations. It can document long-term changes that have occurred in the 43 years after New Horizons sailed past, as well as short-term changes that occurred during its 3-year visit of the Earth. However, it's crucial to keep in mind that there are risks associated with this work. For it to succeed, key technologies must improve. The launch vehicle and the necessary power are the two main dangers associated with the Pani mission. Currently, 5 radioisotope thermoelectric generators, RTGs, are required, but if they require additional power, that number may increase. Additionally, modifications to reduce the mission's overall weight might be necessary if the SLS space launch system or another launch vehicle doesn't function as intended. Nevertheless, the potential rewards outweigh these dangers. Scientists believe Pluto may have a subterranean ocean. It might result in some really intriguing things if they are correct. This suggests that life could flourish somewhere else in our solar system. It also suggests that there may be other types of worlds in the universe where life may flourish. Penny is primarily interested in learning why Pluto has liquid water and why it survives despite being so far from the Sun. Hout claims that in order to unravel these mysteries, we must orbit Pluto because a single flyby is insufficient. We may examine Pluto's gravity signature and observe how it alters the ship over time by circumnavigating it. Though it only examined Pluto for a brief period of time, New Horizons has played a significant role in getting us to consider these issues in the first place. The journey to uncharted territory. The spacecraft began its journey toward Pluto on January 15, 2015. On March 10th, a rocket burn was employed to alter its trajectory. It was so near to Pluto after 2 days that it was closer than Earth is to the Sun. The close meeting was now 4 months away. Images of Pluto started to reveal distinct shapes as April 29, 2015, drew nearer. The knowledge increased every week as the spaceship drew nearer. New Horizons' last engine burn on June 29, 2015, accelerated the spacecraft and improved the accuracy of its trajectory toward the target. However, things nearly went wrong. Due to an error in the scheduling of its directives, New Horizons entered safe mode on July 4, 2015. The crew had to sit and worry for a few days until the spaceship resumed its regular operations on July 7. 3 more days later, New Horizons data finally provided a solution to one of Pluto's most crucial questions. How large is it? Researchers discovered that Pluto is slightly wider than previously believed, at roughly 2,370 kilometers. The moon of Charon was likewise discovered to be roughly 128 kilometers wide. Then on July 14th, New Horizons passed roughly 7,800 kilometers over Pluto's surface. Mission operations received many status updates after 13 hours, confirming that the flyby had gone smoothly. What will happen to New Horizons next? In April 2022, the mission was extended a second time, potentially enabling solar system-related investigations that benefit NASA's astrophysics and heliophysics departments. The probe is currently inside the Kuiper Belt and in good health. It is traveling away from the Sun at a rate of 300 million meters each year. In order to conserve fuel and maintain its condition, it entered sleep mode in June 2022 and remained there until March 2023. What did they find? The excursion undoubtedly altered the way scientists thought about Pluto. We discovered that several of our preconceived notions about Pluto were incorrect. The probe approached Pluto after 10 years of traveling over 3 billion miles, providing us with the clearest image of the planet's surface to date. In addition to Pluto, NASA also had a clear view of Charon. Mariner 2 marked the start of NASA's lengthy history of planet exploration 50 years ago. That journey, however, ended with this pass. Strange territory that is unique to the solar system was depicted in the images. But it wasn't the end. Almost all of the theories that claim Pluto was a dormant ice ball have been refuted or overturned. In the 5 years that have passed, New Horizons data has demonstrated that Pluto and its moons are far more complex than previously believed. Scientists were astonished to see how much activity was occurring on Pluto's surface. Haze in the atmosphere and a lower than expected rate of air escape forced a significant re-evaluation of earlier models of the Pluto system. New Horizons Chief Alan Stern expressed his excitement, stating that the solar system has saved the finest for last. The team's choice of a planet on the fringe of the solar system could not have been more significant or fascinating for science. For 15 years, the New Horizons team planned and executed this flyby, and Pluto exceeded their expectations. The difficulty was worth it for Pluto. Pluto is a very frigid world, but after much effort and time, scientists now know that it is a vibrant, active, and scientifically significant world. It's interesting to note that it might even have data that can help us understand other minor planets that are located distant from the Sun. Naturally, Pluto and Arauco, an object in the Kuiper Belt, have previously been examined by New Horizons. What else is expected of this ship? Things in the Kuiper Belt can lose their focus. Regarding the New Horizons spacecraft, NASA is unsure of what to do. They are unsure whether they should continue with the original purpose of the probe or begin working on another scientific project. This has angered several people, particularly Alan Stern, who expressed his confusion and disappointment in a meeting. Of the 3 suggested years, NASA only consented to send the probe on its next voyage for 2 of those years. Stern had hoped for a more all-encompassing approach that would integrate other scientific disciplines. Rather, they must handle a distinct review within a single division. Stern is certain that shifting the focus may make it more difficult to research fascinating new discoveries in the Kuiper Belt. He bluntly illustrated on a slide how this decision contradicts the mission's initial objective. Stern further supported his argument by highlighting the positive results of New Horizons' evaluation, noting that it had numerous advantages and just one minor drawback. However, after reviewing the study, which indicated that the probe had very little risk of colliding with other objects in the Kuiper Belt, NASA made their decision. Like a needle in a pile, more items are difficult to locate in the Kuiper Belt. According to NASA, the probe can advance science in fields including astrophysics and heliophysics. We won't discover anything new about Pluto until decades later, regardless of NASA's decision.